Okay, just to give an example of how appreciative you should be of that site that you can punch a matrix in and it does the system of equations for you. I'm actually going to do one by hand so you can kind of see how what a pain it is. So what we're going to do, we have 3 equations and 3 unknowns. We're going to do what's called Gaussian elimination. So it's the same thing you could do with 2 equations and 2 unknowns, except it's a little bit more tedious when you have 3 equations. So we're going to dive in. So we can add and subtract equations as we see fit. So probably the best thing to do here would be to subtract this equation from this equation. And the goal is to get rid of this c. So we have 2 equations and 2 unknowns. So let's subtract these two. 30 minus 30 is 0. 1 minus 0 is 1a. 1b minus 0b is 1b. And 1c minus 1c is 0, so that goes away, which is what we want. Now we have to do the same thing, except this has to be informed by this 3rd equation so that we can complete the elimination essentially. So we're going to do, let's subtract this equation from this equation. So 20 minus 30 is negative 10. 4a minus 1a is 3a. And then 2b minus 1b is 1b, which is fortunate because that'll cancel a little more easily. Okay, now we've got 2 equations and 2 unknowns, so that's a good thing. Now all I have to do is eliminate one. We could solve this in a number of different ways, but probably the best thing to do would be to subtract. We can subtract one from the other just to get rid of these b's. So let's subtract this one from this one. Negative 10 minus 0 is negative 10. 3a minus 1a is 2a. And then 1b minus 1b, that just goes away. Great, so we get 2a equals negative 10, or a equals negative 5. Okay, now that we know that a is negative 5, and that's been informed by both of these equations here, we can plug in a negative 5 anywhere for a, and then figure out our b value as well. Probably easiest to do this, right? So 1, okay, so there's our a value. So let's see, 1 times negative 5. Why am I doing that up there? We're going to take this equation and plug in a negative 5 for a. Let's just do it down here. So we get 0 equals 1 times negative 5, so it'll be negative 5, plus 1 times b, or plus b. We could add 5 to both sides to get 5 equals b. Okay, so now that we know that a is negative 5 and b is positive 5, we can go back to any one of these original equations and plug in 5 for b and negative 5 for a. Probably the easiest one to do here is going to be this first one. 0 times negative 5 is 0. 0 times 5 is 0. So we end up getting c as 30. So let's say we didn't have that, because that's a little bit too easy. Let's do it with this one, just so you can see what it normally ends up looking like. So we get, let's just bring this down here. We get 20 equals 4 times negative 5 plus 2 times 5, replacing that b with a 5, plus c. Okay, so 4 times negative 5 is negative 20, plus 5 times 2 is 10, plus c equals 20. We can add 20 to both sides here. We're going to run out of room. Let's go up here. Add 20 to both sides, so we get 40 equals, and we just got rid of that 20. Let's see, plus 10 plus c, subtract 10 from both sides, we get 30 equals c. Okay, so that's the basic idea of how you do a system of 3 equations and 3 unknowns. You want to get rid of one variable by means of all 3 equations. That's what we did here. Then once you get to 2 equations and 2 unknowns, you know how to solve it from there. This is about as straightforward as you're going to get of a system of equations like that. You can imagine if you had decimals, all kinds of ugly numbers, or we had to multiply things, and it was very fortunate that we had a 1 coefficient in all these last terms here. So you can see how this could get really tedious. And if you add another equation, another unknown, this would probably take me an hour, and it certainly wouldn't fit on this board. So hopefully you appreciate the fact that you can just punch this into a matrix and voila, it gives you the answer. So hope that was helpful. Bye.